Hi.
Hi. Are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi. Are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hey, hi everyone. Very good evening to all of you. Welcome to our live mock DSA interview session. And let me quickly introduce myself. My name is Suniti, and I'm a mentor at GeeksforGeeks. And in today's interview session, we have Ishant as our guest. So I'll add Ishant. Yes, hi Ishant.
Yeah, hi ma'am.
How are you?
Yeah, fine. What about you?
Yes, I'm also doing great. Thank you. Okay, so let us start with your introduction. Can you please introduce yourself?
Yeah, sure, ma'am. I am Ishant, and recently I am graduated from Vellore Institute of Technology in 2022 with Information Technology branch. And currently, I am working as a backend developer in Tata Unistore Limited with Serviceability team. So my tech stack there is Golang and Nebula, a graph database. And I have also interest in the data structure and algorithm in problem solving. So yeah, and yeah, I'm doing programming in the Java. So yeah, this is all about of me.
All right. Thank you, Ishant, for your wonderful introduction. So, before we start, would you please let us know that how much would you rate yourself on the scale of 1 to 10 on the basis of your DSA skills?
7 to 8, ma'am.
All right. That's pretty great. All right. So, I'll just explain to you what I'm going to do is like a doc link has been shared with you, right? You can share
Yeah,
your screen and open that document, and in that I will be giving you the questions, and then you can start solving the questions. First of all, you will let us know your approach, and then once we are done with that, then you can start coding. All right.
yeah, sure, ma'am.
Okay, so yeah, so
Is
here
my
is your
screen visible?
yes, it is visible. So let me start the question. So we are going to start with our first question, and that is that given an array of integers, you need to find the number of distinct characters in every window of size k. Alright, k is also given to you. K is also given to you. Okay. So let me write the first test case. Say your array is 1, 2, 1, 3, 4, 2, 3. Okay. And the output for this will be 3443. Okay, so that's because the first okay, k, the value of k is 4. Yeah, that's because the first window of size 4 is 1 2 1 3, right? And the distinct elements that we have here is 1 2 and 3. That's why the count is 3. Similarly, the next window of size 4 is 2 1 3 4, right? So that's why the number of distinct elements in it is 4, and so on. So, is the question statement clear to you?
Yes, ma'am.
Okay, so are the test cases clear to you?
Yeah, ma'am.
Okay, great. So we can start working on this question.
Yeah, sure. So first, I'm starting with the basic approach that comes into my mind is we can take k as a like window from 0 to k minus 1, and in that particular window of size k in that particular array, so we calculate the number of distinct elements using the uh, creating a separate array into that and storing the values into that, or we can use the hash set also to storing the values in a particular window of k size.
Okay,
So yeah, can
and
I write a like pseudocode for that, or
yes, sure, please go ahead.
yeah, sure, ma'am. So we need to return a void type or anything. Okay,
You need to return an array actually, like
okay, sure. So
yeah.
and number of distinct elements. So so my approach is basically first we can use the hash set of because hash set is basically it's used is only creating the unique elements. It's not duplicating elements. So first I am taking the window of size like k from the starting. So let's say we have the window like there is a given a value of 4. So if we are starting then the initial size
Okay,
like let's suppose
just a second. You just mentioned that you will be using hash set, right? Can you
yeah,
clearly describe which data structure you are going to use?
hashing mem because
Hashing is an
we,
algorithm. You have to use a data structure to implement it, right? So, what data structure you are going to use?
yeah, I am using the hash type data structure hash map. Oh, sorry, hash set,
Map.
and in the optimized approach, I will use the hash map.
Okay, so now you are going to use set, right?
Yeah, set,
So, will that be an unordered set or the normal set?
the normal set.
Okay, that will not be an unordered set, right?
Yeah,
Okay, so what is the difference between just a set and unordered set?
ma'am. Basically, the in Java we basically directly use the sets only hash set, and
Okay, all right. Okay,
yeah,
you can go ahead.
yeah. So if we are like I have to write the pseudo code or directly the code.
Okay, so this is a brute force approach, right? So for this,
Yeah,
you can write the pseudo code, and for your optimized approach, you will need to write the entire code. And I will share the link for that. You can just code in there, and then we can compile and run. For brute force, you can write the pseudo code. It will do good.
yeah, sure, ma'am. So first, I am assuming there is a two variables. That is, first one is I index, and second one is jth index. And jth index is pointing to k minus one actually. So and I index is pointing to starting element because I am taking the window of size of all of the windows of the size k. So on a particular from I to jth index, I am creating the hash set basically. That is. So I'm creating this hash set and adding the all the elements from this window of the size k, like from the index I to j. So I mean from p equals to. So here I will add all the elements in the hash set because it creates the unique elements.
Yes, inside the
And
set, only unique elements are added. Okay.
yeah, so after this, if the in this particular case, so one will be added into the hash set, two will be added. So one again the one is coming, so it will not be added in the hash set because it contains the unique elements only, and then it will add the three. So there will be the size of the hash set will be the three, and finally we return the there is a and finally answer will be so size of the output is 6 minus 4 to 7 minus 4 plus 1. Yeah. So output will be size of the n minus k plus 1. So we will directly append the elements here, like after the hash set of the size. So answer of the size is hash set of the size because it's written the size of the unique elements in that particular window. And then we will extend the j pointer and the I pointer. And then again, we came up to new window of size k, and then we append the elements accordingly.
Okay. So can
Yeah.
you write that part? How are you going to do it for the next set of size k?
Yeah, sure, ma'am. So here I equals to 0 and k equals to this one. So when this k is going till when the n minus 1. Yeah. So first it
Are you sure you are
getting
going to
this window.
increment here? Yes, okay.
Yeah. So it's basically first getting the I equals to 0. So there is I and j is equals to in that case is 3. So first it getting all the elements from 0 to 3, window size 4, and return the size of that like return the size of the unique elements in that window, and then increment the size of the both the indexes. So I is now 1 and j is came to 4. So now it's again iterate through the array from I to j and adding all the unique elements. So like this is it is working. So this is
Do you
like first approach. Yeah.
Okay, so do you think this approach is going to work? Let us say if our array would have been 52134, right?
5.
52134.
And what is k, ma'am, here?
K is 4, it is same. Okay, yeah.
Okay.
So initially, what our set will contain in the first iteration?
It will contain 5213 because
Yeah,
first
so
four
size will be
element here. 4.
okay.
That's its
What
idea.
will it contain in next iteration?
Yeah, in the next iteration, it will. So sorry. I have to clear the hash set. Yeah, no.
Exactly.
I make the hash set. Yeah, all time new. So yeah, and the next iteration, it will contain the values of 2134.
But so the distinctive element is 4, but the size of the hash set will be 5, right? Because 5 is still there inside our hash set. Are you
Yeah,
getting my point?
yeah. I am getting your point, but if we are extending the index, then I am creating the new hash set always. So it will iterate over to the I to j always. Like I'm creating here hash set in the while loop.
So how can we avoid that? Like how can we remove the element?
Yeah, because we append the element to the answer array and then increment the pointers I plus plus and j plus plus. When the j is less than or equal to n, then it's creating the new hash set. It's not using the previous hash set.
All right. Okay. So every time for the new loop, you are using a new hash set. So the previous
Yeah,
element will
ma'am.
not be contained there. Okay.
Yeah,
Okay. So what is the time complexity of this code? Every time a new hash
yeah,
set is also created.
yeah. So time complexity will be up. While loop is going in the big of n time. Upper bound is n time, and the inner this is k time. So big of n star k, the time complexity.
Okay. And the space complexity?
Space complexity for this approach is, ma'am, I am using the hash set always and the answer array of the size n minus k. So the upper bounded it is by n minus
You
big
can
of
ignore that.
n.
You can ignore the answer vector because that is what we need to return. So you can ignore that. Just only take into account the hash set.
Okay, so it will be big of k because every time the window size is maximum k. So it store the maximum k elements at a time.
Okay. And all right. So we need to now just move toward the most optimized approach. So what do you
Yeah.
think would be the most optimized approach for this?
the most optimized approach for this, we can use the uh, hash map for this, like hash map. We can, yeah, ma'am, we can store the data as the hash map. Like, can I write here in the second approach?
Okay,
Yeah.
just a second. I will share a question link.
Okay.
Okay, so I've shared the question link with you. You can, yeah. Now, for the most optimized approach, you can write your code here. And
Yeah, sure, ma'am. So my
I just do
optimized
the
approach will
component.
be okay. So first write test 3 4 2 3. Yeah, and the k value is the here 4 and n is 7. Yeah, so my optimized approach will be there in the basic approach. I am using the hash set every time and like iterating over to the window size of the k every time. But here I am using the sliding window technique. In that technique, basically I am first get storing the value of the window first window of size k into a map data type structure. So in the key value pair, like every element there is a frequency stored. For next window, I'm basically deleting the like previous element and adding the next element. So like this I am not going into the every size of the window case. So this approach will become the big of n approach, upper bound by the n.
Great. And how are you going to keep the count of the number of elements which are
Yeah, ma'am.
distinct inside the current window?
Yeah, so for that particular thing, I am for in the hash map, like basically I'm returning the hash map dot size, because hash map also store the all the unique keys, and values are the basically the frequency of each of the elements. So first, like the optimized approach, like first hash map store the values as for first window of size k as one like one with the frequencies 2, and key 2 and well frequency is 1, and key 3 and frequency is 1. So this is the like hash map of the first window. But if I am going to the second window, then I am deleting the first element, so frequency become 1. For the first element the frequency become 1, and like this is the window, and 2 become 2 again 1, 3 again 1, and 4 will be added to the hash map. So I will return the at last uh, size of the hash map, because it contain the unique keys in that window. If
Okay, great.
for any particular window, like if there is a particular key in that window, if the size, if the frequency of that is 0, will be 0, so I will be remove this element from the hash map, because this will creating the extra size of the hash map that I don't want. So I will be removing that element from the hash map, and again I get the like unique element from that window.
Okay, great. So
And
can you just code it?
yeah, sure, ma'am. So first I am making the answer array list that I have to return, and for like I will create a hash map of the size integer, like of the data type key value pair, both are the integers. Key is a element in the array, and value is the frequency of that element of in a window, particular window. So yeah, ma'am. So these are the two basic things that I need. And for the first window, I am storing the details. So like I am creating two index. First is pointing to my initial index, and second one is pointing to my k minus one index. So I am going till when the size till the size of the array. So and now I am storing the elements. So if the for the first window I have to store all the element in the hash map initially, and afterwards for the other windows I am deleting the previous element and adding the next element. So for the first index I am storing the all the values. So uh, for int p equals to if the I am checking if the particular key is present in the hash map or not. If it is present, then I'm simply incrementing their frequency count.
Okay.
Yeah. And if the particular element is not present till now in the hash map, so I will simply put the frequency is 1. So, ma'am, till now, are you with me, ma'am? Or yeah, hello, excuse me.
Yes.
Yeah, ma'am. So till now, are you with me, ma'am? Because
Yes.
like
Yes. Yes.
first window is yeah, yeah.
Yeah.
So
Your code is 3. You can go ahead.
yeah, so the hash map will be created for the first window, and like yeah, that we will do later. Yeah, for the next all the windows, because I will be increasing to the next pointer, and they will be also increasing to the next pointer. So we have to delete the previous window elements like previous I pointer. So first we will what we will do, like we will be simply deleting that element a of I, and getting their current frequency and reduce by -1. So then we will checking if the current value if is reduced to 0 in the hash map. So it means this particular element is like nowhere exist in the current window. So we will simply remove this particular key from the hash map. And if it is
Uh,
exist, then there is no
all
problem.
my just all my beautiful like all the audiences out there, very good evening to all of you. Welcome to our session. And also, if there's anything that is running on your mind, you guys can just keep on interacting in the chat section. All right. So yeah, welcome to today's session. Yes, Ishant, continue.
Yeah, and then like first I will delete the previous element from the previous window. Like now I need to append the next fourth element. So that will be the in that case jth plus one element. So what I will do in that case. So first I am checking if this particular element key is present or not in that case. So if the key is present, then I will simply increment the count of that count of this particular key, and if the key is not present, then I will simply put that key and increment like giving the value 1, because the initial frequency is the 1. So yeah, and now yeah, so if I goes to 0, and this is for the other all the other windows, and at last what I will do, I will increment the ith count and jth count, and also adding the hash map dot size. So
Okay, and then maybe you want to return your answer array.
yeah, ma'am. Finally, we will return the answer array.
Great. Can you just compile and run this?
Yeah, sure. Three three four four. And my output will be yeah. So 1213, that is 3. 2134, it will be 4.
All right. Okay. Can we just do one thing for our first window of size k? You have added
Hmm.
it inside the while loop as well, right? So can we do it like this? Maybe for the first window of size k, you can create a different loop, and from other windows after that point, maybe that you can put inside the loop. Like, all right, you're getting
Yeah,
my
sure.
point. For the first, yeah, for the first window of size k, don't keep it inside this while loop. Just maintain a separate loop for this.
Yeah, you
Yes.
mean sp-
Just write a loop for this.
yeah, so basically, no, no.
A simple for loop from 0 to k minus 1.
Yeah. So basically, yeah, you mean like first window of the size k store simply in this.
Yeah, exactly. And then add that value to the array. And then from after that, you can do it with the help of while loop. Because all those answers are now dependent on this window, right? We are deleting the first
Yeah.
element and adding the current element.
I'm checking that, and then so yeah, so this will be first window will be creating, and then I am starting from the j equals to kth size. Like it's I equals to 0, then there's no need of this. Yeah, so I am simply checking for the ith element is like removing the ith element, and then if the it is will be 0, then I will be removing them, and then checking for the jth element, adding into this, and then increment the I by 1 and j by k plus 1. So be adding for this.
Okay, what are you doing in line number 57?
Line number 57, ma'am, I will be removing that particular element. Like if I'm shifting to this window, then I need to remove this one particular one. And if
Yes,
the
yes.
frequency of 1 will become 0, then I need to remove this value from the hash map. So
Okay,
that
all
I,
right. All right.
yeah. Oh, sorry, I forget to add.
All right, you can just submit the code. Great, Ishant. Congratulations. You were able to solve this. It was wonderful. So, can you help me with the time complexity and space complexity of the code?
Yeah, sure, ma'am. So the time complexity for this will be I am using here the it will be upper bound by n, because I'm not using any k size of the window that I'm used in the basic approach. So this will be upper bound by n, and for the space complexity, I'm using the hash map of the size k. Maximum it will be go of the size k. So yeah, it will be size space complexity.
Okay, great. That's pretty much correct and what I was expecting. So, nice. Let us move to our next question. Okay. So, I will quickly write it down. So, the next question is given an array of non-negative integer representing height of the container, return the container contains closed block. Right, I will just explain you the test case. Like say in the test case we have 1543. Okay, so what is this 1543? These are height of a container. Okay, numerous containers are given to you and the height of these containers are 1543 placed on a straight line. All right, so what is the maximum water that they can contain is water contained is water contained max will be, see, from 5 to 3 the breadth will be 2, right? The index value, like this is at index number 1 and this is at index number 3, right? So the index difference is 2, so the breadth will be 2. And if you are considering the containers 5 and 3, so till what height you can fill the water? You can fill water till the height 3, right? So what will be the maximum water contained? That will be area of that rectangle, which will be 3 into 2 6. So you need to return 6 in the answer. All right, so that is the question. You are given an array. It only have non-negative integers, and obviously not necessarily in sorted order. And you need to return the container which will contain the most water. Okay, so that is your question. Is it clear to you?
Ma'am, like they are the containers situated on a like simple plane, like height 1, height 5,
Yes,
height 4, height 3.
exactly. Like 1543, you can take it as they represent y-axis, and they are
Okay,
placed on x-axis, right? And
okay,
1543 are their height, and index number are their values on the x-axis.
okay. So the length, like this will be our answer. Like length will be the 3 here. So can you explain me again the test case that you have written?
Exactly. Yeah, sure, I can. See, what will happen is we have 1543, okay? Say 1 is placed at index value 0, 5 is at index
Okay,
value 1, 4 is at 2, and 3 is at 3, okay? Now, we want to have a container which will having the maximum amount of water. So, okay, let me show you one thing. Say, what will happen in the first case? If you are taking containers, say 1 and 5, okay? So, what will be their breadth? 1
breadth
minus
will
0.
be, yeah, 1 minus 0, 1.
Yeah, difference in the index value. And see, if the containers, if the one side of the container is of length 1, and if the other side of the container is of length 5, then till how much length you can fill the water inside it?
Yep, uh, that will be 5. 5 minus 1 is the height and 5 is the height. So 1 will be 1.
No, yeah, like see, if you have a container, right, and
Yeah,
one height in one side you have till one length, and on the other side of the container you have 5. So you can't fill above one, right? Otherwise it will start flowing, because above
yeah,
one there
so
is, yeah, you're getting this thing. You can't fill it above one. Okay, the maximum limit to which you can fill it is one. No matter on the other side it is 5, but on this side you can't fill it above one, right? So what is the maximum length to which you can fill it? That is one. Okay, so what is amount of water that it will contain? It will contain 1 unit. All right, now let us see in
okay.
second example. We have 1 and 4. Okay, here it is 1 and here it is 4. So what will be the, sorry, what will be the breadth of this container
It will be
if
3.
it is 1 and 4?
Oh, sorry, 2.
Yeah, 2 minus 0, right? And now tell me, if you are having a container whose one side is 1 and other side is 4, so how much water can you add in that container?
The maximum water that I can is 4 unit.
Can you
Because 5
add?
minus 4, because there is a 4 also.
No, 5 is not. Just don't consider 5 now. You are only having a container with 1 and 4. Okay, one side of the container is of length 1, and other side of the container is of length 4. Okay,
Okay, okay. So yeah,
5.
it will be 1.
It will be 1 again, because
2.
you can only fill it till 1, right? Because you can't fill it more than 1, otherwise it will flow. Okay, so it will be again 1. So
Okay,
maximum water stored here is 2. Okay, now let us suppose the container is 5 and 4. Okay, one side of the
okay.
container is 5 and the other side of the container is 4. All right, so in this case, tell me what will be the breadth.
5 minus 4 is 1. The breadth
Breadth
will
is
be 1,
actually
yeah.
the
1.
difference in the index value.
Yeah, 2 minus 1.
Yeah, exactly. So 2 minus 1, that will be 1. And what is the maximum height till which you can fill the water inside it?
4.
Exactly, you can fill it till 4. So we here have the maximum water contained is 4. Similarly, now are you able to understand why 5 and 3 leads to 6?
Okay, so basically we have to check of only 2 containers and they
Yeah,
can
you
store the
only have to
maximum.
check, exactly. You only have to check for 2 containers.
Okay.
Like in the if you are considering one container, in that container you will having two sides only. Okay, two elements you can take as
Yeah,
the
yeah.
side of the containers. All right. Then you have to
Okay.
return what is the maximum water that can be contained in that container.
Yeah, so yeah. So, ma'am, basic approach that came into my mind is first approach is we can use two for loops. Basically, the first for loop is going over to the array, and the second for loop is going to the from the next index to the last element of the array and checking like which one is the maximum. We can take a variable maximum and like getting the results of the maximum.
Okay.
Uh,
And what will be the value inside the maximum? Like, how will you be calculating it?
that will be index minus index, so it will be j minus ith index and multiple of the difference of their heights, like absolute value of the difference of their heights. So using this, can I write the
Okay. Sure, it is. Okay,
approach?
see, your length part was correct, like difference of the index j minus I. But I guess your height part, are you sure it will be the differences in their height?
No, no, differences in their index.
Okay,
uh,
and what will be
like
their height?
height will be the differences of their heights, absolute value of the differences of their heights, and the breadth will be differences of their index. So both
Okay,
multiply, we will multiplying these values and like compare with the maximum value till now and return the final result as a maximum.
okay. So can you write the pseudocode for this?
Yeah, sure, ma'am. Like we have to return the int value and like yeah. So first I am going till lambda minus 1, and I also taking a max variable that is now containing the minimum value of the integer, and then uh, I am going to next index till last element of this, and then I am comparing this max value with the index subtraction, that will be my breadth, multiply with the absolute value of my height of the containers. So that will be array of j minus array of I. Yeah, and finally I will be return the max.
All right. Are you done?
Yeah, ma'am.
Okay. So now tell me one thing. Suppose we are having a container one and four, right?
Okay.
That was there in the array. One and four are there. You can just scroll up a little
Oh,
bit.
sorry. Yeah, I understand what you mean. Yeah, the length will, because we are taking the two containers. So the uh, but the
See, you are
five
correct
comma
about the
four.
base. The base will be the difference of their index value, right? Your base portion is correct.
Yeah.
Just think about what will be the height. Okay, out of
Oh,
1 and
sorry.
5.
Height will be the minimum of the both, because the container stores the like 5 and 4. So the container stores the minimum of the water. Like
Exactly.
uh
Exactly.
yeah.
Now
So
you get it?
sorry. I'm yeah. I'm like it will be minimum of the both. Yeah. Sorry, I was confusing about that. Yeah.
That's fine.
So
Okay.
yeah, the minimum of the
All
both.
right. So, what is the time complexity of this code?
This is like big of n square, where n is the length of the array, because we are
Exactly.
using the two for loops. Yeah.
Yeah, okay, that is correct. And the space complexity, we haven't used any space, right?
Yeah, we have not used any extra space.
So, okay, let us now move towards the optimized approach. If any approach is coming in your mind, by looking at the logic, what we are exactly aiming at, I will just share the question link.
Ma'am, have you shared the link?
Yeah, I just shared it now.
Okay.
Yeah. So you can now start with the optimized approach because it is taking n square, right? So maybe we can do it in a linear time. By the way, you have quite an impressive GFG score. Here we have people who are like praising this score. So yeah, that's great.
Yeah. Like I was connected with this GFG from since like 2.5 years. More than that, yeah.
That's great.
Yeah. So it will be 1 5 4 3, and the size of the array is 4. Yeah. So we can do for in the most optimized approach is basically we have to find the j minus ith and the minimum of the height. So exactly we need to maximize the value of the j minus ith for this. Uh,
See the first point that you mentioned that we exactly want to maximize j minus I, right? So what could be the maximum value of j minus I?
n minus 1.
Like what will be the value of j?
J will be n minus 1 and I will be 0. So maximum value of the j minus I is can be n minus 1.
Okay. So think of anything so that we can start from that point. Maybe we can start our code by taking them at the initial points. Like that
Okay.
is the maximum base that we can get. Okay. Now you need to think what is the maximum height that you can get and how you can get it.
Minimum height will be for every index in the left side and the right side can be exist. Like for the every element of the 5 will be exist and 3 will be exist.
Okay, so first of all, let us start with the first point as 0 and last point as n minus 1, right? So we are
Yeah.
sorted on the base part. Now you tell me what will be wanting. Like, we will be traversing our loop till I will be less than j, right? That we will be
Okay.
doing. Like, let us say I
Yeah.
starting from 0 and
We can do one thing here. Length is the like length is the array length. Yeah.
okay.
So
So
um, yeah, I understood. Like we can do one thing. Like if the sorry, yeah, if the I will be the starting index and j will be the last index, then we can basically getting the result j minus I. That will be at the breadth and like getting the height minimum of the both of these. So if like we the height can be getting this can be maximized if we are going into the left side, like we can increment the I plus plus or j minus minus. We have the two things,
exactly.
so we can get the
So
result from both.
how are you going to
Yeah.
decide whether we are going to do I plus plus or whether we are going to do j minus minus?
Yeah, that we can decide based on the it's basically if we increment the height, then this index will be reduced to less, and this, yeah, is j minus I 0 and 2, that's 2 minus 0, and This will be 3 minus 1 is 2.
Okay. Let me. So let you just let me know. Suppose you are having one container with side one and one container with size side four. Okay, which container would you prefer? Like suppose you have to select only one side. Which side will you prefer? Side one or side four?
Yeah, I will be prefer for
All right. If you are given a side five and
yeah
if you are given
4
side four, so out of five and four, which side will you prefer?
out of 5 and 4. Like I will be choose for the maximum because this will get me maximum result.
Exactly. So, okay. So, suppose 5 is at index I, and let us say we are considering 3. 3 is at index j, right? So, whether
Uh,
we have to do I plus plus or whether we want to remove I or whether we want to remove j, like, okay, whether we want to reject 5 or whether we want to reject 3. How are we deciding it?
yeah, based on the ma'am, can I taking the second test case because I have
Yeah,
to like
sure, sure.
checking. Yeah, so like this will be my ith and this will be like jth. So now I am getting the 5 and 3. So minimum it will be 3 and the like yeah. So I am shifting to the whichever height that I am getting the best result, like 4 or 3. That the 3 will be minimum. Like I am getting to 1 or 4, then 1 will be. So I'm here. I am reducing the value of the j because this j will reduced because this getting me the result of the 3. So I am checking for the like first yeah. So the first index of mine is the initial element of the array and the last jth is the ending of the array. And then I'm going like I'm incrementing I plus plus or j minus minus. These two I have the choices, so I'm going with that choice that gives me the
Okay,
best result,
so
and that I'm selecting the best result accordingly. If I am getting the whichever value is getting the increment. So that is my approach, ma'am, that I can think it will be working.
okay, like let me know one thing. Out of 3 and 5, you kept the side 3 and you rejected the side 5.
Yeah.
Why?
No.
Why did you kept 3 and rejected 5?
We
Didn't
can
we want to
also
keep the maximum side? Yeah, exactly. So did you get the point?
okay, yeah.
How we are comparing? We are keeping the maximum side and we are deleting the minimum side, right? Out of the two, whatever is the minimum, we are deleting it. Okay, we are doing the increment on that part. Getting my point? Like obviously, you will want to have the container with the maximum size, right? So for maximum size, you need to have the maximum length. So out of the two integers, whatever is of the maximum length, you will keep that, right?
Yeah, ma'am, but I have a question in my mind. Like, if this is a particular case, so if I'm choosing this particular case, then this will return me result 0, 1, 2, 3, 4, 4 minus 1, 3, 3 star 1 actually.
Just a second.
And if I'm choosing I as 3 and jth as 4, then it will be return me 3 star uh, 3. So it will be 9. So that's why I'm going with that point, if I'm not wrong.
Yeah. Tell me. Okay, all right. So first of all, when we are at 3 and 5, then what is the maximum water container that we can have? The maximum content of water when we are at 3 and 5.
Yeah, so we have the 12 value will be the 12 maximum value because
Okay,
0 and 4 and minimum will be the 3.
all right. Now let us say we
Yeah,
will
so
do I
value will
plus
be
plus,
12.
right?
Yeah, so if we do I plus plus, then it will be 3 star 1.
Okay, so what is the size now? I mean, water container. Okay, 3. All
Yeah,
right.
4
Now,
minus 1 is 3, 3 in minimum. And if I'm like, if I'm going with my approach, then it will be I and it will be J. So now it will be same 3 star 3 9 that I am saying.
But
it is returning the maximum result here.
like it is not the maximum answer that we need to have, right? Because the
Yeah,
maximum water that we can get is 12, right? So whether we are getting 9 or not, it will not create any effect. Getting my
yeah.
point? I mean,
It
because 9 is not the maximum answer, so we are not missing out the correct answer, we are just missing out on one potential answer. So of course that is why we
yeah,
are using the optimized approach, because we don't want to check for all the elements, we just want to check for the potential elements which can help us in the maximum container, right? Because see, in the for loops,
okay.
obviously you were going to check for all the containers, so like that was the widest range of the test cases that you can have, like checking for all the elements. But here we don't need to do that, we just need to think logically so that how we can minimize the number of comparisons. Getting my point? So even if we
Yeah,
are not getting
I'm
right, we are
getting
not
it.
at loss. Okay. So
Okay, yeah,
now maybe you can proceed with the code if it is clear to you.
yeah. Sorry for yeah.
I mean, is it now completely clear to you?
Yeah, yeah, ma'am. I am able to understand, ma'am, what you want to tell.
Great.
Yeah,
So now
because
you can.
this will be like a potential result, but yeah, this will not returning the maximum result.
Exactly.
Yeah, so while we can iterate when the till I is less than pointer j. So yeah, and we need to define a maximum variable that will contain the minimum value initially, and this maximum value uh, j minus I, and the minimum value of the container, minimum value of the container heights. So and then we will reducing the j or increment the I based on the height. So I guess this, if the array of j is basically greater than the array of I, then this will yeah, and we return the maximum.
Okay. Now you can just compile and run your code.
Yeah, sure. Okay. Oh, sorry. For the minimum result, we have to return the zero. Sorry.
Great. So very
Yeah.
well done. I have solved this question, and like you are able to get the logic of the question, right?
Yeah, yeah, ma'am. I am able to get the logic because first I am thinking in the like second test cases, or like thinking about the finding the approach basically, like where I'm getting the, so that's why. And another approach that came into my mind is the we can use the like recursion basically to getting the maximum of the result. But here it is simple, like we can choose over the maximum, so we have to move into the one situation.
Exactly.
Yeah,
And can you tell me the time complexity of this code now?
yeah. The time complexity it will be upper bounded by the, because the length of the array. So yeah, it will be upper bounded by the length of the array because I is pointing,
So that is,
and space it will be one big of one.
and the time complexity is linear, right?
Yeah, linear.
Great. So uh, yeah, Isha. So that was great. Just solving the questions and all those. So before we jump into the feedback session, first of all, I would like you to ask yourself how much would you rate yourself on the basis of this interview?
Now, ma'am, on the second problem, I think I have to decrease my rating.
Okay, so how much would you
Mm,
decrease it?
yeah, I think uh, six. Or like, what's your feedback on that?
All right. See, a six is quite low. You did great. All right. In this interview, you did great. There are like lots of plus point that were there, and the first point being is that you were confident throughout your interview. Okay, that is a very nice thing. All right. Usually, what happens is that sometimes we do write the wrong code even for the things that we are already knowing. Why? Because we lose confidence, right? But you were confident throughout the interview, so that's a big plus point. Next is that your communication skills are great, right? You were communicating in a very nice way. You were able to understand my thoughts and you were able to express your thoughts in a very clear manner, right? So that is a very big plus point. And then working in a team, if such kind of things are there, a great communication skills, then it becomes easy to work, right? So yeah, your communication skills are great. And then next, the variables that you were using, right, you were naming them correctly. So that is also a nice thing. So sometimes what happens is that when we write long codes, at that time if the variable names are not suggestive, then it becomes sometimes it becomes cumbersome to understand what exactly the variable is doing here. So you took care of all those things, so that is great. The first question went amazing, so I would rate you 10 on 10 for the first question. For the second question, I would say that you did use some hints, right? So keeping that in mind, a little bit of help was required. And I guess maybe there was a lack of little logic on your side. Like, okay, you were not able to develop the clear logic, but with the proper communication, you were able to get on the logic part, right? So you utilized your strong points in a very good way, right? And then you were, finally able to figure out the answer. So for the second question, maybe I would rate you 8.5 out of 10. And for this entire interview as well, I will be giving you 8.5. The interview was great. Okay, you performed really great. All right. Maybe the second question,
Thank,
but as if you are able to reach to the final answer, right? If you are able to figure out what you're doing, so some amount of hints can be used. So that is nice. So yeah, that was a great interview session with you, and yeah, thanks for getting connected with us. Anything, any feedbacks from your side?
yeah, ma'am. This same, ma'am. This was a very great interview. Like I also think like you explained me like in the second problem. Like yeah, that's a great option. Like because in that manner, like if I'm going to the solving that problem, like I go over. Basically, I'm going over to the second two or three test cases. Then I will make, and then I'm going into the some or more methods, and then maybe I will use the recursion. Basically, like yeah, it's a very good interaction with you, ma'am, and yeah, thank you so much, ma'am.
Actually, the your if through the entire interview session, you were very calm, very confident, and you showed great communication skills. So that's why it was great, solving questions and then getting to the final answer. So that was great interacting with you. Good job.
Thank you, ma'am.
All right, Nishant. So thanks for getting connected with us. Bye and have a good day.
Yeah, have a nice day, ma'am. Thank you, ma'am.
Most welcome. All right, guys. So there he was. We had Ishant with us, and there was a great interview session. As you all see, he performed great. All right. He showed great communication skills. He showed great logical abilities. He was, very confident. So that are some of the plus points that you guys can keep in mind. And if any of you is interested to be a part of this mock interview session, then the link is provided in the description section. Please do fill out the link, and that is a Google form. So do fill out and get a chance to feature in this interview session. So any feedbacks from your side? Yes, thanks, Shagun. All right, guys. If there is anything anyone would like to mention, okay. So thanks for being with us in the session. Thanks for responding. Thanks for giving the correct answers. Many of the answers were really correct. And so, I would love you all to fill out that form. So maybe, we can have you all in our next interview session. That was all about it today. All right. So, bye, guys. And yeah.